Okay, today we're going to do one-to-one functions. This is, what section is this? 1 point, what are we, I don't even know what. 5? 4.
We did 1.4 last.
No, we did do 1.4. This is 1.5. Okay? Now, in this section, in 1.5, they also talk about parametric equations. We are not going to do that today.
I hope we practice outside.
Okay? Parametric equations and one-to-one. Now, what do we know when we get a function that's one-to-one? There's a lot of words in here. There's a lot of different things that it talks about and goes on about. Okay? A graph represents a one-to-one function if wherever you draw a horizontal line through any value in the domain, it intersects the graph only once. If the horizontal line crosses the graph more than once, it is not a one-to-one function. Okay? It's just like there is a vertical line test. This, for a function, we do a horizontal line test for one-to-one. Okay? All right. Note that it must also satisfy the vertical line test, okay, to be a function. A graph represents a function if whenever you draw a vertical line through it, any value in the domain, it intersects the graph only once. If any vertical line crosses the graph more than once, it's not a function. All right? So you've got two things going on. It has to pass the horizontal and the vertical, and then we know it's one-to-one. All right. Take a look at each of these graphs. Does this one pass the vertical test?
Yep.
All right. So the vertical test, check. We're fine. What about the horizontal test?
Nope.
No.
No good.
When I draw that, it'll pass through twice. Not working.
Ah.
Okay? What about the vertical line test for this one?
Yep.
Horizontal?
No. Yes.
You.
Yes. This function is one-to-one. Okay? What about the vertical test?
Yep.
Nope.
Okay? And horizontal?
No.
All right. Not one-to-one. This one, which one does not work?
Horizontal.
Vertical check, horizontal no.
I always get those mixed up, you know.
Okay? What about this one?
Both of them work.
Okay, so this is one-to-one.
Thanks.
All right.
What does the one-to-one mean? Means that.
That-
Good.
No, that just means that for every
Type of function.
one value of x, there's one value of y, and vice versa. For every one value of x, there's one value of y.
Oh, yeah.
Okay, here I have one value of y, and there are two x's that
Yeah.
correspond to it. So that's why one-to-one means there's only one each. All right. One-to-one functions directly relate to what's called inverse functions. Okay? Inverse functions, they undo one another. This is how you write it. This does not mean 1 over f. Okay? It doesn't mean that. It just means inverse in the sense that you can undo it. Okay? All right. A function must be one-to-one in order to have an inverse. Okay? If a function's not one-to-one, there is some values that do not work. Which functions above have inverse functions? Which ones did we find to have one-to-one?
First one, the third one, fourth one.
Okay.
The second and the last.
The second one, g of x,
Yeah.
and the last, w of x. Which ones do not have inverses then?
First.
Others.
Yep, f of x, what was it, s of x, and u of x. All right. Give numerical examples that explains why y equals f of x equals x squared does not have an inverse function. Right there, okay? A numerical example would be,
What is it? Sin x, like f of x, and what is it?
s, x, it's g, okay? All right. Okay, what they mean by a numerical example is kind of like what I set up there. If y equals 4, then that means that x can equal 2 or negative 2. And that is not one y value, and it has two x. They asked me to do a numerical example to show that it does not have an inverse, and 4 is an example of that. Because 1 to 1 means there's one x for every one y. And in this case, I have two x's that equal the same y. Okay? All right. This is the mathematical definition of an inverse function. Now, the reason that they put this section after the other one is because it has to do with the composition of functions. Do you see that? It's got all this composition of functions. Now, before we begin, do you remember how to find the inverse of a function? No? Okay? The first thing you're going to do, once I start writing these steps down, you might remember, the first thing you do is you switch the x and y. And then the second thing you do is you solve for the y.
Is it almost like the negative reciprocal? Just
Um,
without the negative?
Yeah, it could be like that.
So just the reciprocal,
Well, but it doesn't really mean reciprocal.
but it's the same thing.
Is it X
No.
and Y or X plus Y? Like
And x and y. Well, I'll do one right here. Okay? Show that these functions are inverses of each other using composition. Show your work. All right. This is the inverse of that. Okay? Over on this side, I'm going to show you how they got this to this.
Wait, what?
Sorry.
Okay.
All right, am I right?
Solve for what? Solve for what?
Okay. I'll show you. Oh, did I not?
Solve for.
Sorry. Why? Sorry, Mason. Okay. If you take this function and what did I say was my first step over here? What did I have to do? Switch?
Switch the X and Y.
Okay, so x equals 12y plus 7. Then what does my number 2 step say?
Number two.
Solve for Y.
All right. How do I solve for y here?
You just add and subtract 7.
All right, let's subtract 7 first. And then what do I do?
You just divide by 12.
Oh my goodness, we found.
That then, notice, is my inverse function. They did it for us. I wanted to show you how they got that. So these two functions, they say, are inverses of each other. And we're going to show that by using composition. Okay, so this is what we need to do. We need to take the f function and put it into all the x's of the inverse function. All right? So, I take this function right here. I need to find the inverse of 12x plus 7. Put this in for the x. 12x plus 7, and then minus 7 over 12. Does everybody see where I got that? Okay, I took this whole thing and I put it in for that x because that is my inverse function. Now I simplify it. What is 7 minus 7? 0. I get 12x over 12, and that equals x. Okay, and that's my definition. If I take the inverse of the f function and I get x, and then I get it again, then they're inverses. All right, let's try this one right down here. Okay, I need to find f of x minus 7 over 12. I'm going to put all of this in for that x right there. Okay. Jack, well, how would I simplify this now?
That you would,
Is that a 7
There's
minus
no
7?
idea, just multiply.
It's an x
12
minus
in
7?
No. Is that a 1? 12x plus 7 minus 1?
Minus 7? Sorry, that's a 7 there, yeah. Could I cancel anything first?
yep.
Yes, the 12s.
The sevens you can get rid of.
Yep. And because I ended up with just an x at the end, these two functions, they are inverses of each other.
What does OF stand for, you think?
That has to do with the composition that we talked about. This little thing right here.
Yeah.
What that means is that the f of x function, right down here, goes on the inside of the inverse function. Whatever's after. This means f of it, meaning put that function inside the other one. So it's easier, it's probably a bit easier to understand when it's written with parentheses like this, other than like that. Okay? Does that help, Kyle?
Yeah.
Okay.